Welcome students. Today we will discuss some questions on stereochemistry and conformational analysis appeared in CSIR exams. Now in 2021 this question came that correct relationship between the following structures. So these two structures, if we investigate, they are actually identical. These two compounds are 5,6-dimethyl bicyclo 2,1,1 hexane. Now this molecule does not have any chiral center, so there is no question of enantiomerism. They are no way enantiomers, and it is appearing that these two are the mirror images, but because this molecule is achiral, so mirror image will be superimposable, means they are homomers or identical. In this question we have to find out the most stable conformation in case of the tetrachloro 1,4-dioxane. If we investigate the given compound, then it is clear that the vicinal dichloro are having trans stereochemistry, means when we will convert it into the chair form, then vicinal dichloro should occupy di-equatorial or the diaxial orientation. Now keeping it in the mind, if we see the given options A, B, C and D, then B and C we can cancel, because in B and C the vicinal dichlorides are not trans oriented, they are cis oriented because they are axial equatorial. Now after cancelling B and C, we have to pick up the correct answer between A and D. So between A and D, the D is the correct option, because that is due to the anomeric effect. When the electronegative atoms are present adjacent to the oxygen, then equatorial orientation will be unstable than the axial orientation. So based on these, the D is the correct answer, because the 4 electronegative atoms are axially oriented in the D. So in this regard, I would give the caution that in place of oxygen, if the sulfur atoms are present in the ring, then they are in that case not the axial orientation, but the equatorially oriented group will be more stable. In that case, if sulfur is present, in that case anomeric effect will not work. This Newman projection is for substituted cis-decalin, not for trans-decalin. And the circle which is present at the center, that is actually representing the 2 carbons of the ring junction, usually in the numbering which comes at the number 9 and the 10. Usually adjacent to the 9 carbon number 1 comes, and adjacent to the 10 carbon number 4 comes. So if we give numbering, then the methyl substitution is coming at the C2, backside key C3, C3 is connected with the C4, C4 is connected to the C5 of the other ring, and like that if we map, then completely from the carbon number 1 to carbon number 10 all will be given numbering. And now coming to the methyl substitution at the C2, that is methyl substitution is coming at below the plane, it is equatorially oriented. So based on that, the options will be A and C, any one of these two will be correct, the B and D will not be the answer. Now after giving all the numbers from the carbon number 1 to the carbon number 10, it is very clear that 2 methyl groups are coming at the C2 and the C6. So that numbering is available in the option A, so therefore A is the answer, not the C. Now let us come to the next question of 2019. Now there were 2 conformers A and B, those are trans 1,4-disubstituted cyclohexane. A conformer has 2 equatorially oriented R groups, and the B conformer has the 2 axially oriented R groups. Now the question is like that for which group B conformer will be more stable. Now there are 4 options. Option 1 methyl, option 2 fluorine, option 3 chlorine, option 4 methoxy. Now in case of out of these 4, in 3 cases, means if the R group is methyl, R group is chlorine, or the R group is methoxy, means option number 1, 3 and the 4, obviously equatorially oriented A conformer will be more stable than B. So indirectly it is the option 2, means if the group is fluorine, because of its extremely small size and the extremely high electronegativity, those two fluorine atoms can be axially oriented at the 1,4 position in trans diastereomer. Now coming to the next question, that here also they have given the two conformers A and B, and they are asking to find out the relationship between A and B. Now if we investigate these two compounds, then it is clear that it is a combination of the EZ and RS system. Now if we consider with respect to EZ, now the two compounds A and B, both of them they have the double bond, and both of them have the double bond geometry E, because the two hydrogens are oppositely oriented. And if we give the priority, the first priority groups are in the opposite side, so therefore whether it is A or B, in both the cases the double bond geometry is E. Now coming to the third position, where we have the methyl group and that center is a chiral center, and if we do the RS, then in case of the A, that absolute configuration is coming as R, and in case of the B, that configuration is coming at S. So it is a combination of ER and the ES, so therefore these two are enantiomers. Now next coming another question in the 2019, that we have to identify the most stable conformation of one given molecule. That molecule comes under the alkyl-leading cyclohexane category. Now in this case, if we investigate the four structures given 1, 2, 3, 4, then 3 and the 4 are no way possible, because they are something related to the both conformer. So either the answer will be 1 or the answer will be 2. Now in alkyl leading cyclohexane, which factor we have to consider is the allylic 1,3 strain. Means the two groups in at the 1 and the 3rd position, they should not come close, because they will undergo the steric crowding. So that type of allylic 1,3 strain is present in the structure given in the option A. So A is not the answer, B is the answer, because that allylic 1,3 strain is not there in the option 2, where the methyl groups are completely opposite side oriented. Hence the final answer will be 2. Now coming to the another alkyl leading cyclohexane substituted compound. So here we have to find out whether this molecule is chiral or achiral, and if it is the chiral, then whether it will be having the R configuration or S configuration. So first of all, this molecule comes under axial chirality, and this molecule is chiral. So based on that, this molecule does not have any plane of symmetry. This molecule also does not have any center of symmetry, because if plane of symmetry or center of symmetry are present, then molecule will be achiral. Now this given molecule is chiral, and now we have to find out whether it has the R configuration or S configuration. So now for that we have to stand on any side of the compound. So we are standing, take it for granted, in the left hand side. So here we have to draw the cross, and the near group precedes over the far group, that we have to apply. Now that hydrogen and the carboxylic acid, they are in the right hand side, and the carboxylic acid is in the right hand side, hydrogen is in the left hand side. So like that if we put, and then the remote side ki carboxylic acid is above and the hydrogen is below. Now we have to apply that sub rule, that is near group precedes over the far group, and the near groups are specified by putting one thick arrow. Means here horizontal groups, carboxylic acid and the hydrogen, they will be against the thick line. So carboxylic acid will be having first priority, hydrogen will be having the second priority. Now going to the rear, remote side, there also carboxylic acid and hydrogens are there. In this case, carboxylic acid will be having the third priority, hydrogen will be having the fourth priority. Now 1, 2, 2, 2, 3, if it is clockwise, then it is R. In this case 1, 2, 2, 2, 3 is clockwise, so therefore it is R. At the fourth position hydrogen is there. We have to completely ignore when we will do the RS nomenclature for the axially chiral molecule. Hence our final answer is 2. This is chiral and having the R configuration. Now next, coming to a substituted 1,3-diaxane, we have to find out what is the most stable conformation of the given molecule. Now in this substituted 1,3-dioxane, methyl and the hydroxy groups are above the plane, and so therefore we have to find out the cis compound, not the trans compound. So methyl and the hydroxy group, they are present at the 1,4 position relatively. So di-equatorial and the diaxial, if any orientations are there, they are not representing the cis conformer, they are representing the trans. So therefore the option 2 and option 4 are no way answer. Now we have to investigate correctly the option 1 and 3, out of them which one is the correct answer. Now in case of the cis compound, one will be axial and another will be equatorial. Now we have to see the methyl will be axial or methyl will be equatorial. Now here we have to concentrate on the carbon versus oxygen. So carbon is bigger size than the oxygen, so therefore the bigger group will prefer to go to the equatorial and the other one will be axial. So in this case methyl will be equatorially oriented and the hydroxy group will be axially oriented. That conformer will be the final answer. That structure is given in the option 1, so therefore final answer is 1. Now in this case we have to find out the number of optically active stereoisomers for the given compound. Now if we investigate the given compound, there will be 3 chiral centers, but these 3 chiral centers are repetitive. So therefore in order to find out the number of total stereoisomers, there will be one formula, 2 to the power of n minus 1, where n is the number of the chiral centers, means here 3. So 2 to the power of 3 minus 1 means the final answer will be 2 square, means the 4 stereoisomers will be there. Now if we draw the 4 stereoisomers, from that it will be very clear. The 2 comes under the optically inactive meso category. So therefore 4 minus 2 is equal to 2 will be the optically active stereoisomer. So now that answer is available in the option 1. So therefore option 1 is the correct answer. Now coming to the next question, here we have to find out the most stable conformation of 2-fluoroethanol. Now in the given options 1, 2, 3, 4, there are 2 eclipsed form which are given in the option 1 and 3. Those 2 will be not the answer. Now we have to investigate the second option and the fourth option. In the second option it is the Gauche form, and in the fourth option it is the anti-form. Now usually we know anti-form predominates over the Gauche form, but in this case, as because fluorine and the hydroxy group, they will participate in the intramolecular hydrogen bonding, so that will stabilize the Gauche conformer, not the anti. Hence the final answer will be 2. Now next, coming to the another question where we have to again find out the most stable conformation of one substituted cyclohexane, but in this case the cyclohexane has the 2 tertiary butyl group at the 1 and 4 position. Now we have to know that these 2 tertiary butyl group, we have to put it into the equatorial position, then only most stable conformation will come out. Now based on this, again we can cancel the option 2 and the option 4, because option 2 is a boat form and the option 4 is the twist chair form. Those are highly unstable. So therefore we have to concentrate on the option 1 and the option 3. Now if we concentrate on the option 1, the 2 tertiary butyl groups are there, but the 2 tertiary butyl group ki, one is equatorially oriented, another one is axially oriented. So hopefully this will not be the answer. So now we are going to the option 3, where both the tertiary butyl groups are oriented in the equatorial way, means those are all twist equatorial orientation, because the basic skeleton of the cyclohexane is the twist boat form. But as because both the equatorially oriented tertiary butyl groups are present in this conformer, this will be the final answer. Now coming to the next question, here we have to find out this compound is chiral or achiral. And if it is chiral, then it will be having the p configuration or it will be having the m configuration. Now the given compound is one substituted phenanthrene and it has the helical structure that is due to the molecular overcrowding, and this molecular overcrowding is arising due to the presence of the two closely related methyl group. Now everybody knows that helix will be chiral, and so therefore this molecule is also chiral. So based on this, option 3 and option 4 are cancelled. Now we have to find out whether it has the p configuration or it has the m configuration. Now starting from the close methyl group which is close to the viewer, if we go to the another methyl group which is away from the viewer, then it is through the clockwise movement, so therefore it will be having the p configuration. Hence our final answer is 1. Now coming to the next question, here in the given compound there are geminal methyl groups are there, and we have to find out the topic relationship between the two methyl groups, means are they homotopic, diastereotopic, enantiotopic or constitutionally heterotopic. Now by looking at the structure, it is very clear that these two methyl groups are exchangeable with respect to symmetry of first kind, means the simple axis of symmetry, means these two methyl groups can be exchanged with respect to the C2 passing through the midpoint of this molecule. So therefore these two are the homotopic. Now coming to the next question, where we have to find out some trimethyl cyclohexane is given. All the three methyl groups present in this substituted compound are oriented in the same side, and that is above the plane. So based on these, the option 2 and the 4 are not the answer, because in the option 2 and option 4 the methyl groups are not oriented above the plane. Some methyl groups are above the plane, some methyl groups are below the plane, so 2 and 4 will not be the answer. The final answer will be from 1 and 3. Now if we investigate the option 1 and option 3, then there are 3 methyl groups are there in option 1. 2 axially oriented methyl groups are there and 1 equatorially oriented methyl group is there. Coming to the option 3, 1 axially oriented methyl group is there and 2 equatorially oriented methyl groups are there. So we know that equatorially oriented groups are more stable in comparison to the axial. So here in the option 3, less axially oriented methyl group is there. So therefore our final answer is option 3.